Today's lesson, lesson 9, sinusoidal modeling. We're on pages 380 and 381 of our textbook. You want to have one colored pencil. I'm probably going to use red, and a graphing calculator. Okay, so now we're finally going to look at real-world models. The key to constructing or interpreting a sinusoidal model is understanding the physical meanings of the A, B, and C coefficients defined in the last 3 lessons. So for y equals a sine bx plus c and y equals a cosine bx plus c, remember that the amplitude is equal to the absolute value of a. It's the distance the sinusoidal model rises and falls above and below its midline. We also know that we can get our a value by taking the max minus the min dividing by 2. C, the midline or average y value. The formula for determining that based on the max and the min, well, it's the average. It's the max plus the min divided by 2. B is the number of cycles in 2 pi. It's related to the period. B is equal to 2 pi over p. Capital P, the period, is the minimum distance along the x-axis for the cycle to repeat. So remember, period is the length of one complete cycle. Or one full cycle. The formula for period is 2 pi over b. And let's put in the range here also. Let's add in the range. The range is equal to c plus or minus the absolute value of a. So in other words, from there, the maximum value would be c plus the absolute value of a, and the minimum value would be c minus the absolute value of a. Exercise number 1. The tides in a particular bay can be modeled with an equation of the form D equals a cosine bt plus c, where t represents the number of hours since high tide and d represents the depth of the water in the bay. The maximum depth of the water is 36 feet. So we have a max of 36. And the minimum depth is 22. We have a min of 22. So right there, given those two values, we can figure out what A is, because A is going to be max minus the min divided by 2. And we can figure out what C is, max plus min divided by 2. High tide happens every 12 hours. This 12 hours is the period. On the axis, sketch a graph of this scenario for 2 full periods. Okay, so we need 2 full periods. Label the points on this curve that represent high and low tide. Well, the period is 12. Then we need 24 hours. So we want to sketch it first. Okay. So I'll put 24 out here. And let's see, approximating halfway, that's 12. And this is a cosine, and it's starting at, this is the number of hours since high tide. So it's going to start at its max, come down to its min, after 12 hours be back at its max. That's going to give us one cycle. And then from 12 to 24, we'll get a second cycle. The max is 36. So if I put 36 up here, and I'm going to try to kind of split this in half. Half of 36 is about 18. Seems a little high. Maybe I'll try to bring it down here. 18. And let's see, midway between 36 and 18. Why can't I think? That's 8. That is 18. So that's 9. It'd be about 27. All right, so I'm going to mark my 22 about here. All right, I've got a max of 36, a min of 22. I don't like that. It seems a little high. I'm going to mark 22 down here. Okay. So it starts at high tide, at its max. After 12 hours, it's going to be back at high tide. And after 6 hours, it'll be at its min, which is 22. From 12 to 24 hours, we'll get our second cycle in. And half of, let's see, 6 there is 18. Okay, so there's our sketch of 2 full periods. Label the points on the curve that represent high and low tide. So this is a high tide at 0:36. This is a high tide at 12:36. And high tide at 24:36. And low tide at 6:22. Just gonna try to make that a little better there. There we go. And 18:22. Determine the values of A, B, and C in the model. Verify your sketch is correct using a calculator. A equals max minus min divided by 2. 36 minus 22 is 14 divided by 2 is 7. So A is 7. I'll just go in alphabetical order. B is 2 pi over P. Our period is 12, so we'll reduce that to pi over 6. And C is the max plus min divided by 2. Again, please keep writing these down because you have to have these memorized, right? A equals B equals C equals. So keep writing the formula. That will help you memorize them. The max was 36 and the min 22. What is that? 58 divided by 2 is 29. So here are A, B, and C values. So when I go to put it into the calculator, right, I'm just going to put it down here. So it's going to be y equals 7 cosine pi over 6 t, but we'll use x, plus 29. So we go to y equals, keying in the equation, 7 cosine pi divided by 6 x, close parenthesis, plus 29. Go to the window, and we want to go our x's from 0 to 24. Our x scale, I'm going to say I'm going to go by 6. The y min is 0, and well, yeah, I'm going to leave it at 0 to 30. I always like to see a little more. I like to see the top a little more than the top of the graph, so I'm going from 0 to 40. And I'll go by, I guess I'll go by multiples of 2. And now if I press graph, if I didn't miskey anything, hopefully we should find a graph that looks similar to what we have on paper. Okay, so that looks good. Yeah, this was 40. So that mark up there, I don't know if you probably can't see it. That's 40, and then 38, 36. Okay, so that looks good. Tanker boats cannot be in the bay when the depth of the water is less than or equal to 25 feet. Write an inequality and solve it graphically to determine all points in time, t, on the interval t going from 0 to 24, when tankers cannot be in the bay. So when the water depth is less than or equal to 25 feet. So that means our 7 cosine pi over 6t plus 29 is less than or equal to 25. When is that the case? Well, in y1, we have our equation 7 cosine pi over 6 t plus 29. And then in y2, let's put in 25. Let's see if I can get this so that there isn't. All right. Basically what's happening here, can't get the glare away. That's a little better, not much. So basically it's from here to here. That's when the water level is less than the 25 feet, less than or equal to 25 feet, right here. And then also here. All right. So we have to use the calculator to calculate the points of intersection. What's the time at this point here, and this point here, and then the other two, right? So we do second trace. Maybe I'll write this down. Or second trace intersect. So second trace, number 5. First curve, it's on our cosine. It jumps to the line. And now second curve's okay. For the guess, I want to put it to the leftmost point. All right. And rounding that to the nearest tenth. Oops, I never drew it on my diagram above. So let's draw it above here. This is approximately 25. All right, this is our D equals 25. And now this point to the nearest tenth is going to be 4.2 comma 25. Second trace, number 5 again. First curve enter, second curve enter. For the guess, move it closer to the other point that we want. And this is 7.8 comma 25. And they are 12 hours apart, so you can just add 12 to the 4.2 and the 7.8. But I should put that on, at least on the graph here, the other 2 points of intersection. So adding 12 to the 4.2 is 16.2. Right? And if you don't believe me, of course, you can go ahead and second trace, number 5. First curve enter, second curve enter for the guess. Move it closer to the other point, and that's 16.16, which rounds to 16.2. Okay, so 16.2 comma 25, and this is going to be 7 plus 12 is 19.825. Okay, so the tanker cannot be in the bay between the time of when the time is greater than or equal to 4.2 hours, but less than or equal to 7.8, and also 16.2 less than or equal to 19.8. Or if you're using interval notation, 4.2 comma 7.8 in brackets, 16.2 comma 19.8. Oops, sorry about that. Okay, number 2. The height of a yo-yo above ground can be modeled using the equation h equals 1.75 cosine pi t plus 2.25. Let me switch to purple, which I've misplaced. So this is A, this is B, and that is C. Where h represents the height of the yo-yo in feet above the ground, and t represents time in seconds since the yo-yo was first dropped from its maximum height. Determine the max and minimum heights that the yo-yo reaches above the ground. Show the calculations. Okay, so we want the max and min. Well, the max and the min. The max is C plus the absolute value of A, and the min is C minus the absolute value of A. C is 2.25, so we want 2.25 plus 1.75, which is 4, and 2.25 minus 1.75. I think of dollars and cents. 2 1/4 subtract 175 is going to be 50 cents, or 0.5 feet. I should label max, min. How much time does it take for the yo-yo to return to the maximum height? for the first time. So in other words, it's asking us, what is the length of the period? Formula 2 pi over b. 2 pi over pi is equal to 2. 2 seconds. Exercise 3. A Ferris wheel is constructed such that a person gets on the wheel at its lowest point, so it's starting at its minimum, 5 feet above the ground. Oh, so that is its minimum, 5 feet. So I'm just going to note over here, minimum is 5 feet. And reaches its highest point, 130 feet above the ground. So the max is 130. It takes 8 minutes to complete one full rotation. Well, that 8 minutes is the period. A person's vertical position can be modeled as a function of time t in minutes since boarding by the equation y equals a cosine bt plus c. Sketch a graph of the person's vertical position for one cycle and then determine the values of a, b, and c. Okay, so we want one cycle. We want a graph of one cycle, which is 8 minutes. We'll put 8 here. And judge halfway. That would be 4 minutes here. And the minimum is 5 feet. The max is 130. So let's say I put 5 feet here. And the max 130. And they get on the wheel at its minimum. So we start here. And then after one complete Ferris wheel rotation, they are going to be back where they started from. And that's after 8 minutes. And after 4 minutes, they'll be up at the max. Okay, so if I can... Now the values of A, B, and C. Well, I'm just going to go in alphabetical order again. So A equals the max minus the min divided by 2. $130 minus 5 is 125. 125 divided by 2 is 65, and 65 is 130, so 62.5. B is 2 pi over P. 2 pi over 8. Pi over 4. And C is the max plus the min. $135 divided by 2 67.5. Now, if I was to write the equation here, y equals 62.5 cosine 67, whoops, sorry, start over. Y equals 62.5 cosine pi over 4 t plus 67.5. Now there's something missing in my equation, right? The midline is 67.5, which think of just judging halfway between these two. If I keep the equation as it is, and the midline is 67.5, in relation to the midline, our starting point, it's not above the midline, is it? It's below the midline. So we need a negative in front of our 62.5 because this is a cosine function that actually starts below the midline. It starts at its minimum. So we would have y equals negative 62.5 cosine pi over 4t plus 67.5. Exercise number 4. The possible hours of daylight in a given day is a function of the day of the year. In Kingston, the minimum numbers of daylight on the winter solstice is 9 hours, so the min is 9 hours. And the maximum hours of daylight on the summer solstice is 15. If the hours of daylight can be modeled using a sinusoidal equation, what is the equation's amplitude? Okay, so amplitude is the absolute value of A. And we know that A is equal to the max minus the min divided by 2. 15 minus 9 is 6 divided by 2 is 3. The absolute value of 3 is 3. Okay, that's it for the lesson, but let me just see the homework. A, at what height was the ball released? Just keep in mind here that since this leading is negative, then it's starting below the midline. So you're actually being asked to find the minimum. It's being released at its minimum point. And we know how to find the minimum. Right, the minimum is going to be, if I think of range, the minimum is going to be C minus the absolute value of A. Right? Yeah, we have a lot of things we have to put up here. Right? We know how to get A. We've had a lot of practice with that. Max minus min divided by 2. We know how to get B. It's 2 pi over P. We know C is max plus min divided by 2. To find the max, it is, well, C minus the absolute value of, or C plus the absolute value of A. and the min is C minus the absolute value of A. That's coming from our range. Right? If our range is C plus or minus the absolute value of A, then the min is C minus the absolute value of A, and the max C plus. Again, none of these are given to you on a formula sheet, so please, please, please make sure you are writing down these formulas each time and then showing the substitutions into them. All right, so I think we'll be okay there. I think 2 should be okay. You're just finding A, B, and C. Yeah, definitely. If I go back up to number 1, draw a rough sketch of one complete period. We'll make sure you find it first. Oh, it's asking you here. C is asking you for the period. So A, you're finding the min. B, the max. C is the period. And then your graph. All right, that should be okay. I believe number 3 might be all right as well. There you're going to get another intersection point for B. Y1 is your equation that is given. Okay. And then Y2 is going to be your 75. You have to use your calculator there. I mean, sketch the graph first, and then put Y1 and Y2 in your calculator. For number 4, I just want to ask you to, finding the A, B, and C values, the maximum percentages. Okay, so use that your max is 50. Don't write 50% or 0.5, just use a max of 50. And your min is 0. And then determining A, B, and C will be fine. Yeah, and number 5, you're just looking for the range, and we have the formula for range. All right, thank you once again for your attention.